We humans get dark spots and blemishes on our skin that come with hormones or aging. For the sun, surprisingly enough, has some cosmetic blemishes of its own. These are called sunspots and can occasionally get squeezed or popped by the sun, which could damage the skin of the earth. Are you getting what I mean? Well, basically the fireworks on the sun can create something called a geomagnetic storm affecting the earth. So let's understand the fireworks on the sun and how that has to do with the colorful light show in the sky. The blemishes on the sun, the sunspots, are relatively dark, irregularly shaped regions on the surface of the sun, with a central dark region called the umbra and surrounding light dark regions called penumbra, much like the shadows during eclipses here on Earth. But for obvious reasons, these sunspots are not the shadows cast by the objects in our solar system. Come on, how can something cast a shadow on the only light source in our solar system? Anyways, sunspot regions on the surface of the sun appear relatively darker as they have lower temperature than the surrounding hotter regions of the sun. With the diameter of the sun equaling 109 Earths put side by side, a typical sunspot has a diameter the size of the Earth and lasts anywhere from less than an hour to a few months. This helped in making some really interesting visual observations of the sun over the last few centuries. Galileo observed these sunspots in the 17th century and discovered that the sunspots near the equator take 25 days to circle the sun, while those farther north and south take longer, up to 36 days all the way near the poles. This is happening not because of the sunspots all roaming around, but due to the rotation of the sun itself. This varying rotation speed is known as differential rotation, a kind of rotation where the rotation period of the body differs from the latitude. Now, how is that possible? The sun is not a solid rigid structure. It is made of gas, that is plasma, which is charged ionized gas. As there is a constant flow of this plasma up and down till the core, this results in convection zones below the photosphere, which is basically the visible part of the sun, and the convection zones move at different speeds at different latitudes of the sun. This churning of superhot charged gases in the convection process creates something called the dynamo effect, generating magnetic fields locally and collectively creating a huge magnetic field around the sun. It wasn't until the mid-19th century that astronomers observed something called the Sunspot Cycle, which is basically a regular increase and decrease in the number of spots on the sun. This is a 11-year cycle where the number of sunspots increase, reach a maximum, and then decrease. And to the surprise of astronomers, in this 11 years of solar cycle, the polarity of the sun is reversed. That means the magnetic field lines of the sun flips, turning north to south and vice versa. As we know, the sun rotates differently at different latitudes. This results in a twisting and bending of magnetic field lines as they get haywire, creating something called the active regions on the sun. The magnetic fields are very strong where the active regions are located, and when hot plasma rises from the sun's interior to the surface, due to the convection, these active regions just push away the rising hot plasma. This causes such areas to become cooler and dimmer than the rest of the photosphere, which by definition is exactly what sunspots are. On one hand, the active regions with strong magnetic fields below the sunspots repel the hot plasma. On the other hand, that is above the surface, it attracts the charged particles surrounding the sunspots, channeling them along the magnetic field lines. These field lines extend out in the atmosphere of the sun called corona, creating a spectacle of fireworks on the sun. And sometimes these huge magnetic loops of plasma with high speeds break out the solar corona, ejecting out into the space called CMEs, also known as coronal mass ejections, or simply called the solar flares or storms. Now let's assume it's directed towards the Earth. These solar storms travel with the speed of 8 lakh kilometers per hour, taking approximately about 18 hours to reach the Earth. When solar storms reach the Earth, something strange happens. The invisible magnetic field of the Earth interacts with the incoming magnetic field, and coupled with charged particles that bend and stretch the magnetic field of the Earth, it funnels down the solar radiation towards the poles, following the magnetic lines and creating a colorful spectacle called the Aurora. Which results from the interaction of the atmospheric gases with the charged particles of solar radiation to produce light. This spectacle could last from a few minutes to maybe even a few hours. Well, aurorae occur so high up in the atmosphere that they don't pose any threat to people watching them from the ground. The aurora itself is not harmful to humans, but the electrically charged particles produced could have some potentially negative effects to infrastructure and technology. While the solar activity and sunspots are serious stuff to study for scientists, but for amateurs and space enthusiasts, it's a recreational activity where they go out to observe sunspots using telescopes, taking utmost precautions while doing so, like using safe solar glasses, solar filters, and age-old projection methods to observe the spots and fireworks on the sun. As always, thanks for giving your space and time.